Introduction to The Outline of Science. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This recording is by Mark Smith of Simpsonville, South Carolina. The Outline of Science, a Plain Story Simply Told. Edited by J. Arthur Thomson. Introductory Note. Was it not the great philosopher and mathematician Leibniz who said that the more knowledge advances, the more it becomes impossible to condense it into little books? Now, this Outline of Science is certainly not a little book, and yet it illustrates part of the meaning of Leibniz's wise saying, "For here within reasonable compass there is a library of little books, an outline of many sciences." It will be profitable to the student in proportion to the discrimination with which it is used. For it is not in the least meant to be of the nature of an encyclopedia, giving condensed and comprehensive articles with a big full stop at the end of each. Nor is it a collection of primers, beginning at the very beginning of each subject and working methodically onwards. That is not the idea. What then is the aim of this book? It is to give the intelligent student citizen, otherwise called the man in the street, a bunch of intellectual keys by which to open doors which have been hitherto shut to him, partly because he got no glimpse of the treasures behind the doors, and partly because the portals were made forbidding by an unnecessary display of technicalities. Laying aside conventional modes of treatment and seeking rather to open up the subject as one might on a walk with a friend, the work offers the student what might be called informal introductions to the various departments of knowledge. To put it another way, the articles are meant to be clues which the reader may follow till he has left his starting point very far behind. Perhaps when he has gone far on his own, he will not be ungrateful to the simple book of Instructions to Travelers, which this Outline of Science is intended to be. The simple bibliographies appended to the various articles will be enough to indicate first books. Each article is meant to be an invitation to an intellectual adventure, and the short lists of books are merely finger-posts for the beginning of the journey. We confess to being greatly encouraged by the reception that has been given to the English serial issue of The Outline of Science. It has been very hearty, we might almost say enthusiastic, for we agree with Professor John Dewey that the future of our civilization depends upon the widening spread and deepening hold of the scientific habit of mind. And we hope that this is what the Outline of Science makes for. Information is all to the good. Interesting information is better still. But best of all is the education of the scientific habit of mind. Another modern philosopher, Professor L.T. Hobhouse, has declared that the evolutionist's mundane goal is the mastery by the human mind of the conditions, internal as well as external, of its life and growth. Under the influence of this conviction, the Outline of Science has been written. For life is not for science, but science for life. And even more than science, to our way of thinking, is the individual development of the scientific way of looking at things. Science is our legacy. We must use it if it is to be our very own. Introduction. There is abundant evidence of a widened and deepened interest in modern science. How could it be otherwise when we think of the magnitude and the eventfulness of recent advances? But the interest of the general public would be even greater than it is if the makers of new knowledge were more willing to expound their discoveries in ways that could be understanded of the people. No one objects very much to technicalities in a game or on board a yacht, and they are clearly necessary for terse and precise scientific description. It is certain, however, that they can be reduced to a minimum without sacrificing accuracy, when the subject in view is to explain the gist of the matter. So this Outline of Science is meant for the general reader who lacks both time and opportunity for special study, and yet would take an intelligent interest in the progress of science, which is making the world always new. The story of the triumphs of modern science is one of which man may well be proud. Science reads the secret of the distant star and anatomizes the atom. foretells the date of the comet's return, and predicts the kinds of chickens that will hatch from a dozen eggs, discovers the laws of the wind that bloweth where it listeth, and reduces to order the disorder of disease. Science is always setting forth on Columbus voyages, discovering new worlds and conquering them by understanding. For knowledge means foresight, and foresight means power. The idea of evolution has influenced all the sciences, forcing us to think of everything as with a history behind it, for we have traveled far since Darwin's day. The solar system, the earth, the mountain ranges, and the great deeps, the rocks and crystals, the plants and animals, man himself and his social institutions, all must be seen as the outcome of a long process of becoming. There are some 80-odd chemical elements on the earth today, and it is now much more than a suggestion that these are the outcome of an inorganic evolution, element giving rise to element, going back and back to some primeval stuff from which they were all originally derived, infinitely long ago. No idea has been so powerful a tool in the fashioning of new knowledge as this simple but profound idea of evolution, that the present is the child of the past and the parent of the future. And with the picture of a continuity of evolution from nebula to social systems comes a promise of an increasing control, a promise that man will become not only a more accurate student, but a more complete master of his world. It is characteristic of modern science that the whole world is seen to be more vital than before. Everywhere there has been a passage from the static to the dynamic. Thus the new revelations of the constitution of matter, which we owe to the discoveries of men like Professor Sir J. Thomson, Professor Sir Ernest Rutherford, and Professor Frederick Soddy, have shown the very dust to have a complexity and an activity heretofore unimagined. Such phrases as dead matter and inert matter have gone by the board. The new theory of the atom amounts almost to a new conception of the universe. It bids fair to reveal to us many of nature's hidden secrets. The atom is no longer the indivisible particle of matter it was once understood to be. We now know that there is an atom within the atom, that what we thought was elementary can be dissociated and broken up. The present-day theories of the atom and the constitution of matter are the outcome of the comparatively recent discovery of such things as radium, the X-rays, and the wonderful revelations of such instruments as the spectroscope and other highly perfected scientific instruments. The advent of the electron theory has thrown a flood of light on what before was hidden or only dimly guessed at. It has given us a new conception of the framework of the universe. We are beginning to know and realize of what matter is made and what electric phenomena mean. We can glimpse the vast stores of energy locked up in matter. The new knowledge has much to tell us about the origin and phenomena, not only of our own planet, but other planets, of the stars and the sun. New light is thrown on the source of the sun's heat. We can make more than guesses as to its probable age. The great question today is there one primordial substance from which all the varying forms of matter have been evolved? But the discovery of electrons is only one of the revolutionary changes which give modern science an entrancing interest. As in chemistry and physics, so in the science of living creatures there have been recent advances that have changed the whole prospect. A good instance is afforded by the discovery of the hormones, or chemical messengers, which are produced by ductless glands, such as the thyroid, the suprarenal, and the pituitary, and are distributed throughout the body by the blood. The work of physiologists like Professor Starling and Professor Bayliss has shown that these chemical messengers regulate what may be called the pace of the body, and bring about that regulated harmony and smoothness of working which we know as health. It is not too much to say that the discovery of hormones has changed the whole of physiology. Our knowledge of the human body far surpasses that of the past generation. The persistent patience of microscopists and technical improvements like the ultramicroscope have greatly increased our knowledge of the invisible world of life. To the bacteria of a past generation have been added a multitude of microscopic animal microbes, such as that which causes sleeping sickness. The life histories and the weird ways of many important parasites have been unraveled, and here again knowledge means mastery. To a degree which has almost surpassed expectations, there has been a revelation of the intricacy of the stones and mortar of the house of life, and the microscopic study of germ cells has wonderfully supplemented the epoch-making experimental study of heredity which began with Mendel. It goes without saying that no one can call himself educated who does not understand the central and simple ideas of Mendelism and other new departures in biology. The procession of life through the ages and the factors in the sublime movement, the peopling of the earth by plants and animals, and the linking of life to life in subtle interrelations, such as those between flowers and their insect visitors, the life histories of individual types, and the extraordinary results of the new inquiry called experimental embryology. These also are among the subjects with which this outline will deal. The behavior of animals is another fascinating study, leading to a provisional picture of the dawn of mind. Indeed, no branch of science surpasses in interest that which deals with the ways and habits, the truly wonderful devices, adaptations, and instincts of insects, birds, and mammals. We no longer deny a degree of intelligence to some members of the animal world. Even the line between intelligence and reason is sometimes difficult to find. Fresh contacts between physiology and the study of man's mental life, precise studies of the ways of children and wild peoples, and new methods like those of the psychoanalyst must also receive the attention they deserve, for they are giving us a new psychology, and the claims of psychical research must also be recognized by the open-minded. The general aim of the outline is to give the reader a clear and concise view of the essentials of present-day science, so that he may follow with intelligence the modern advance and share appreciatively in man's continued conquest of his kingdom. Signed, J. Arthur Thomson. End of introduction.